Hi guys, welcome back to another video. So this time we'll be exploring second order linear differential equations for the non-homogeneous case. So in the non-homogeneous case, sorry, let me set that up really quick. Okay, so for the non-homogeneous case is basically when g of x is not equal to 0. Okay, that sounds a little complicated, but basically last time we explored that second order linear differential equations look something like this, right? And if they are like linear differential equations, so these functions which you see p, q, and r, they will always be like constants. But in this case, I'm just expressing what a second order like differential equation would look like, right? And so if these are always constant, this, and this, it would look something like this. And you can further like simplify this for your understanding by taking y double dash as r square. So it would be equal to a r square plus b r plus c is equals to g of x. And in this case, we're exploring like if g of x is not equal to 0. So that is a non-homogeneous case. We're trying to find a general solution for something that has that is g of x, right? That there is a literal like function here. So how do we solve this? So first, the general solution will always contain the particular solution plus the homogeneous case. So this is the non-homogeneous yp, and then this is the homogeneous case. Okay, so then based on, so you know how to find this, so the homogeneous case, so you just find that, and then we move on to the more difficult part, which is finding the particular solution, which is a non-homogeneous case. So the way you would do this is through using the method of undetermined coefficients. Sorry for my handwriting. So yeah, so basically based on the g of t, the way you want to approach it is like first you solve the homogeneous case, then second you make a guess based on how the g of t looks, like sorry, the g of x looks. So let's say if like there's only going to be three scenarios, so just remember this. If it exists in like, let me make a table. So if it exists in the form a e raised to k t, which is the exponential form, then you always know that you have to use this case, which is like a constant. In this case, I'm taking a e raised to k t. This looks a little confusing because on both sides we have a, but imagine that this is like not actually a variable. Like this is not like, imagine there was like 8 written here, and or like let's say 3. So both of these would like generalize to like falling under this umbrella, because what I'm saying is that a is just like any constant ahead of it. And so we'll so in this case we will use a e raised to kt, and then in the case of either a cos or a sine, we will use this. The b and the beta are different, so like don't confuse them. So basically what it means is a could be 0 in this case and b could also be 0 in this case. So you have like a function g of x which is like cos 3t. 3 is like the beta in that case, right? So this expression would be guessed using the particular solution guess would be a cos beta t plus b sine beta t. And then the third scenario is the nth degree polynomial, which is like t of n. So whatever n is, basically you wanna write a of n t raised to n. Like basically if this was a quadratic, then you would guess it to be like ax square plus bx plus c. So imagine like whatever degree polynomial it is, you make sure to include like a member in each of those cases. So it will go up to this, and then you also need your constant. So we have that. Any other scenarios which are not composites of this we would have to use like let's take for example tan or 1 over b ln. We would have to use variation of parameters, which we'll cover in the next video. So don't worry about it. So basically you just create a guess based on looking at g of x. I guess this is a little abstract, but like you require a guess for the solution of like the yp. So basically once you've guessed it, you go back and then you find like if you guess yp is equals to aekt, then you find y dash of that, and that would be k a e k t, and then y double dash of that, which would be k square a e k t. And you would put that in the solution that you have, which is sorry like the form that you have. Like let's say you have y double dash like 2y double dash plus 3y dash plus 4y is equal to 8e raised to 3t. So over here instead of writing k, I would write 3, and then I would write 3, and then I would make this 3, and then I would make this 9, and then I would make this 3. So then you would plug this in, and then basically you would plug all of these 3 in respectively, and then figure out how there's an 8 in this scenario, and then find the constant for a, and then write yp plus yh as the general solution. Okay, moving on to the more like complex scenarios. Let's say g of x was not just like a single exponential or like trigonometric or a polynomial, but it was a composite of those. Like it was those but like multiplied. Like let's take t e raised to minus t. So in this case we see that t is like the linear composition like component, and e raised to minus t is like the exponential component. So now your guess would have to also improve. You will have to guess based on this fact, and now you'll have to like, so because I have a linear component, what I would do is I would automatically like have the linear component and then multiply, because this is multiplied, so I would multiply it with the exponential component, which is e raised to minus t. And you also, based on this guess that you make, your first guess, right, you look back at the homogeneous case and see if any of your components in your initial guess look very similar or the same thing as like the homogeneous case. And if that is true, then just like add a t, like a1t plus a0 e raised to minus t. Alright, so we know how to handle situations like those. Let's look at a more difficult example, I guess. G of x when it's equal to 7t e raised to t sine t. So in this case we have all the three things, right? We have a linear component, we have an exponential, and then we have a trig, right? So now our guess is gonna be, first we'll include the linear component, which will be a1t plus a0, and it's multiplied by the exponential. And then for trigs, as we know, it needs sine and cosine, so we'll have like, we'll repeat the whole thing because the sine and cosine need to like be balanced. So sine t, and then plus b1t plus b0 plus et cos of t. Alright, so we see how this needs to look. This is our particular guess, right? This is our guess and it looks pretty good, and based on this you can like find y double dash, y dash and y double dash, and then plug that in and then compare it and find the constants. We know how to do that. I just explained it on this slide. Okay, so let's explore the last like scenario that can exist, and that for that we'll use the superposition theorem. So basically we looked at like the composite case where they're like multiplied by each other, but what about the case where they're like added to each other, right? Where g of x is equals to like let's say e raised to 2t plus 8t, anything, right? Doesn't matter. So basically the superposition theorem states that you can like divide these. You can find the particular solution for e raised to 2t, and you can find the particular solution for 8t, and then add them together. So let's define the theorem for you to better understand what I just said. So let's say y1 is a particular solution to this, and as you can see I'm using the same constants like a, b and c because like it's g of x is compared to like 1 second order like homogeneous, like non-homogeneous linear differential equation, right? So the a's, the b's and the c's will be like the same for both of them, but we are just dividing it. So I'm saying that y2 is a solution for the second part. So we can see e raised to 2t will be, this would be like in our scenario, this is what it would be, and this is what this is. But I'm talking about more in a general scenario, right? So we can find that, and then the solution for y1 plus y2, which is the case that we have the case that we need to solve both of these, right? So it's so basically we can exploit this property to we can find the particular solutions separately for each of them and then just add them up in the end. Yeah, so that is it for the superposition theorem, and that is it for the video. I hope you understood.